Okay, recording. All right, guys, let's do 39. Hey, this one's a little bit easier. This one has two, okay? Two positively charged spheres, one 3 times the charge of the other. The spheres are 16 centimeters apart. The force between them is 0.298. What are the charges on the two spheres? So, Coulombs' law. All right, we should be able to find out an actual numerical answer for this, even though they didn't give us the charges for Q. Okay, right? So it's basic algebra problem. 16 centimeters apart. Should I put 16 right here? Why? What should I put? Because metric system. Newtons goes where, Alejandro? Right there, because that's Newtons. Right where the force is. Okay? 9 times 10 to the ninth is Coulomb's constant. So now just put Q and 3Q. Q and 3Q, right? So, excuse me, Q and 3Q over 0.16 meters. Well, can't I just make that 3Q squared? Yeah, I can make that 3Q squared. 0.289, I forgot to square that, 0.16 meters squared times 9 times 10 to the 9, 3Q squared. We are solving for the letter Q again. Okay, so cross multiply and divide. Right there, cross multiply, divide by 9 times 10 to the 9. Don't forget this time to divide it by 3, and then square root. Okay? Christopher, did you get something like 5.2 or 5 times 10 to the negative 7 for just for the letter Q? Does this make any sense to you all, what I just did? Ryan Wood, we're on this, man. This is 3Q, this is Q. 3Q times Q is 3Q squared. We're solving for the letter Q. Don't forget to square root at the end. Multiply these two, divide by 9 times 10 to the 9. Also, don't forget about the 3, and then take the square root. James, did you get a very small number? No, you should get a very small number. Negative 6, you get a... That's close. Anybody get anything else? Okay, well, it says you should get 5 times 10 to the negative 7. Approximately 5 times 10 to the negative for C. So Q is equal to 5 times 10 to the negative 7 coulombs. So all you need to do to figure out what 3Q is, so if this one's 5 times 10 to the negative 7 coulombs, then that would be 3 times as big. Okay, so this one's 1.5 times 10 to the negative 6. And is that what you said, James? Yeah. Okay, that's okay. That's just rounding. Okay? Yes. Divide by K, and then divide by 3, and then square root. So this is the letter Q, 5 times 10 to the negative 7, and then you multiply that times 3 to get the other one. All right, that's Coulomb's law with 2 things only, right? So we'll do one more McDonald's video here, and we'll do this one, number 40. And this has 3 particles, right? And so how do we do that with 3 particles? Well, we're only interested in what 2 of them are doing. Has everybody got this? I'm going to spray bottle this one. Okay, so now here, 3 particles are placed in a line. Okay, particle A, particle B, particle C. The middle one has a charge of, the one on the left has negative 55 times 10 to the negative 6 coulombs. Remember, that's not a mu friction, that's a micro, right? And yes, I know it says negative 55 times 10 to the negative 6. Full disclosure, older kids, illegal scientific notation is perfectly okay. I know I told you in chemistry it was against the law. It's not. Okay. This one, 45 times 10 to the negative 6. Okay. And then this one, negative 78 times 10 to the negative 6. You can put it in the calculator like this, and the calculator will literally fix it for you. Yeah, Sally. You don't have to worry about it. Okay. And the middle particle is 0.72 meters from each of the others. So each one of these is 0.72 meters. Find the net force on B. So what do we have to do? We have to do Coulombs law from A to B, and we have to do Coulombs law from B to C. Fab. Okay. K times, there's A, Q of A, QB, QC. So you have negative 55 times 10 to the negative 6 times 45 times 10 to the negative 6 divided by 0.72 meters squared. Okay. What's that? And we're finding the net charge, Greenie, so that means we're going to add these two guys. Yeah, I know. It's illegal scientific notation, and illegal scientific notation is okay. Yes. Yes. And believe it or not, lots of the stuff you learn in math as being illegal in high school totally is not illegal at all. Like order of operations. Okay, that doesn't exist. Order of PEMDAS does not exist. No, PEMDAS doesn't exist. Doesn't exist. Your calculator goes left to right unless you tell it to parentheses. So really, there's no PEMDAS. It's just P. It's just parentheses. Alrighty, lots of calculations, lots of calculations. If you add those up, your net force between these two guys, well, actually, it doesn't ask you to find the net force. It just, well, yeah, it does. Alrighty, what's this answer for this one right here, A to B? Well, all right. All right, well, okay, so the net force, you're going to add those up. You're going to add up the answers to these two guys. And do you get something close to... Do you get something close to 18? Approximately 18 newtons. Okay? Allie, did you forget to multiply times K? Did you forget this is squared? Uh-huh. Okay, so look at this. James, tell us. Where's the larger negative force? Is it on this side or is it on this side? This one's more negative, so this would be basically going to the right. To the right. Did you get negative? I'm sorry. Did you get negative? Is that what you got? It's okay if you put negative because these are negative numbers. That's fine. It's 18 newtons to the right. Yes, they would be attracted to each other because they're positives and negatives. So that is okay if it's negative 18 newtons to the right. Nope. All right, so I'll look at your math, Hallie. But anyway, smash the bell. Don't forget we have YouTube lives and a quiz on Wednesday. Coulombs law. Do DHS physics. Smash the bell. Period.